okay? As you can see, you're just basically adding a bunch of monomials together. That's all a polynomial is, right? You know, what do you call it, the prefix here? Poly meaning many, mono means one, right? So polynomial means at least one, many. So this is what a polynomial in the variable x is. That's all. Now notice there's some terminology here, namely polynomials can have a degree, namely the degree of a polynomial is the degree of the, it's the degree of the largest monomial. In other words, it's the highest power of x that appears. That's all I'm trying to say. So it's the monomial of the largest degree. That's the degree of, and that's what I'm saying over here. You know, if the coefficient a sub n were, it would not be written. This is also called the leading term because it's the highest power of x. And a sub n is the leading coefficient. A sub 0 here, right? A sub 0, that's the constant term. You could probably guess there's no variable there. Now, there's something else not written on the slide. Notice that if you read from left to right, the exponents of x, right? They're decreasing as you read this from left to right. That's called standard form. So when you have a polynomial written so that the powers of x, the exponents that is, they're decreasing as you read from left to right, we say the polynomial is in standard form. Generally, that's what you want to write your answer as when you do problems and stuff in standard form. All right, let me say this also. There is the notion, just like there was a zero monomial, there's a zero polynomial. That's when all the terms are zero. In other words, all these coefficients are all zero. That's a zero polynomial. And that has no degree. It's just like with monomials. It has no degree. You know, monomials are polynomials. Okay. Well, that was fun. So let's do some examples. Okay. Here, we have one of degree 3, right? We have a polynomial of degree 3, right? Because that's the highest power of x. So we have x cubed minus x plus 2. Term here is x cubed, right? Leading coefficient is 1, as you can see. 2 is the constant term because there's no here. Over here is the same idea, right? We have a polynomial of degree 5, right? Because the highest power of x is 5. So this is the leading term. The leading coefficient is 4, right? So again, the leading term, that's just the term, the monomial, with the highest power of x. And the constant term, of course, is 1. We have those. Notice that these are in standard, right? Because again, as you go from left to right, the exponents are decreasing. The exponents of x. Okay. We have that. Again, these are posted online, the notes. I also posted a sheet. I'm hoping we'll get to that today. Just letting you know. Okay. All right. So these are just some other examples. You know, just some other put in. Hopefully they're pretty easy to see. Right here we have a polynomial of degree 3, right? The highest power of x is 3. Leading term is negative. The leading coefficient is negative 5, and so on. Okay. The constant term is not here, so it's understood to be 0. That's what's happening. You know, if it's 0, we just don't write it. Here the constant term is 12. I mean, this stuff is pretty easy to see, easy to understand. At least I hope it is. And again, just like with monomials, okay? Just like with monomials, a polynomial of degree 0 is just a non-zero constant. It's just a non-zero constant. In other words, the term here and the constant term are the same. Okay, so those are just some easy examples. Okay, so that's what a polynomial is, right? Okay, now we get to move on to adding and subtracting them. Now, basically, it boils down to what we do for monomials. In other words, remember when let me see if I can get back to the slide actually. All right, here we go. Remember how when we combine, we only combine like terms, right? And we do that by adding or subtracting the coefficients. Okay? It's the same idea with polynomials. That's really the underlying idea when you add, here we go, when you add polynomials together or subtracting. The two methods here, they're just different ways of seeing it, so to say. The horizontal method is probably what you have seen already if you have done polynomials before. There's a vertical method. That's just, to me, I think it's better because it's easier to see. Terms are the like terms. I've had students that prefer one method over the other. You know, some students preferred the horizontal method. Some students preferred the vertical method because it's a little more visual. Whatever method you use is up to you. Okay, so first I want to demonstrate the horizontal method. And I'm doing an example. And again, as I said before, you're just basically adding and subtracting by combining like terms. So for this example, we have this polynomial, and we're going to add it to this one. So how do we do that? Well, again, I'm demonstrating using the horizontal method, like so. And really, you just have to visually see which terms are like terms. That's what it boils down to. Okay, okay, so we have the two polynomials here. I put them in parentheses just to make it easier to see. Okay, but for instance, excuse me. Okay, it's 7x squared, right? Is there another term that's of degree 2? That is there a term that 7x squared is a like term with? Well, yeah, this one, right? The wonderful minus 5x squared. So this and this are like terms. These two we want to combine. 3x, right? What's another term of the other like terms of 3x? Well, yeah, minus 3x. Those we're going to combine. 1 and 5, those are like terms, right? We have them here. X to the 4, right? That's the only term of degree 4, so we leave it alone. X cubed is the only term of degree 3. In other words, there's no other terms that's x to the 3rd is a like term with, so we leave it alone. Okay, that's good. Okay, so what do? We combine, right? Here we have 7x squared minus 5x squared. That gives us the 2x squared. That's where this comes from. Oh, it's up here. Okay. 3x minus 3x. That's 0, right? 1 plus 5 is 6, and we have these two. So this is what the sum is. But again, it's good to write it in form where from left to right, the powers of x decrease. And that's what I did over here. Remember, these are real numbers. I mean, x is a variable, but they still represent real numbers, so we can add them in any order we want. So this makes sense. That is, we can do this. That was fun. Let me just stop for a second. Are there any, what do you call it? Here we go. Are there any questions at all? Okay. Let me see. I was going to say, oh, am I going too fast for anyone?
No.
Awesome. Okay. Yes, I'm afraid to ask this, but I'll ask it. Am I going too slow? You can be honest.
Not really.
I was actually wondering,
What?
I forget, when do you know how to add, when do you know when you're supposed to add like the exponents?
Oh, that's when you.
Okay.
Okay. Yeah, the exponents you're not going to change. You don't change the exponents. We do that when you multiply. Okay. Again, if you have a question, I won't get upset. Don't be afraid to ask. Everyone. I want to make sure everyone is learning this. Okay. Okay. Are there any other awesome question? Whoever asked that. Are there any other questions? Okay. Well, okay. So let me keep going then. Okay. Let's see. Is this good? Okay. Oh wow. Oh man, time flies when we're having fun. All right. So, okay. All right. So let me keep going then.